Okay, for our first sample for topic 3, we're going to calculate the gravitational force between you and your backpack, which is not a super interesting or relevant problem, but just give us an idea of the mechanics here. So let's say your backpack has a mass of 10 kilograms and you have a mass of 70 kilograms. And according to the sample, you guys are 60 centimeters apart. So we use R, which I know you're thinking radius. In physics, we often use R as the distance between two objects, even if a circle really isn't part of the conversation. So it's definitely something that you'll see in the future. You'll see it next semester when we do point charges that are a certain distance apart. We're going to call that distance R, and you'll see it if you take college physics. So if you just get used to, if there's no circle around, we're not going to find circumferences or anything like that. But if you come to think of R as the distance between two objects, things will be helpful. So we're going to find the gravitational force, like we said, between you and your backpack. So our formula, which is Newton's law of gravitation, is big G, m1, m2 over r squared, where m1 and m2 are the masses of the two objects, and r is the distance between them. As you know, multiplication is doesn't matter what order you multiply in, so it doesn't matter who's m1 and who's m2. We'll have to be more careful of that in the future, but today it doesn't matter. So today's really just a plug and chug problem where we use the universal gravitational constant. Now, as far as we know, this constant is constant everywhere in the universe. The unit is a bit of a fudge factor so that we come out with a force in newtons. Remember, on the back of your formula sheet, this constant, is given. So don't panic if you can't remember it. Sometimes I forget it as well. But there it is, okay? The two masses, again, in no particular order. And then over here we have a distance of 0.60 meters. Now, some of you guys write really small. Don't forget to square that, okay? So we plug and chug and life goes on, and we end up with 1.3. And I really should have kept another digit here, but I didn't. So we'll keep it at 1.3 times 10 to the minus 7th Newton. There's our answer. Now, that is a tiny force, and I'm going to say this again many times this chapter. Gravity is far and away the weakest of the four fundamental forces. And the force that you and your backpack, remember, you exert a force on the backpack exerts a force on you. Both of those forces are easily overcome by the friction, first of all, between you and your chair, and then between the backpack and the desk. So, this force is nowhere near overcoming Fs max to actually have you get pulled towards it. And also keeping in mind that for every 10 kilogram backpack that's pulling you towards it, there's something of 10 kilograms behind you pulling it towards that. So because gravity is so weak, and because in this situation is being canceled out by so many other things, there's no noticed acceleration in either direction. But this is our first shot at using Newton's gravitational formula.